This is a story about a continent that had a past. Not a geological past, not a scientific one, but a real one. A warm, green, living past. About a place known today as the coldest, driest, windiest place on Earth, and which once looked utterly different. I'll tell you about a transformation that took tens of millions of years, and about an ending against which no chance remained. Not for a single creature, not for a single forest, not for a single current. What's at stake here is not one species and not one epoch. At stake is an entire world built over 150 million years, forests from coast to coast, rivers where long-necked giants brought their young to drink, warm seas where marine reptiles the length of a city bus glided through, armored tanks and swift predators with sickle claws. All of this lived, breathed, reproduced, hunted, on a continent that stood almost at the planet's very southern pole. And it lived not because it was barely scraping by, but because the earth under its feet was generous, warm, green. This world had only one enemy, slow, silent, leaving no tracks behind: time and tectonics. The continent was preparing for a leap that would rewrite everything. The crust was preparing a crack. The ocean was preparing a ring of icy water around the continent. The sky was preparing a fall that no one saw coming. And together they assembled the longest execution in the planet's history, stretched over tens of millions of years, slow, absolute, with no right of appeal. And how would you put it? Which is more frightening? One sudden blow that kills everything in a few years, or a slow cooling against which neither courage, nor any adaptation, nor any cunning of evolution can do a thing? What do we, people, used to our own short lifetimes, usually underestimate the most? The bright catastrophe or the quiet, relentless inertia of millions of years? Listen, that's exactly what this story is about. Forget everything you know about our planet, because 90 million years ago, Earth was completely different. Not slightly different, but fundamentally, unrecognizably alien. Picture this: several times more carbon dioxide in the atmosphere than in the pre-industrial era. The planet's mean temperature 6 degrees Celsius above our norm. Just 6 degrees, you might think, a trifle. But 6 degrees of average temperature is the difference between our world and a planet with no ice at all. Not at the North Pole, not at the South, not a single glacier, not a single ice cap. The whole planet green and blue, only land and water, without a single white spot. From this follows one inevitable thing. All that ice covering Antarctica and the Arctic today is a colossal reservoir of frozen water. In the Cretaceous, it did not exist, and global sea level was 100 to 250 meters higher than today, and at peak moments, almost a quarter of a kilometer higher. Take a familiar map and picture this. All of western Siberia, not a plain of taiga and oil, but a shallow sea stretching from the Urals to the Yenisei and connecting the Arctic Ocean with the warm southern Tethys. Tyumen, Surgut, Khanty-Mansiysk, Novosibirsk, all of its seabed, across which ammonites and huge marine reptiles glided. The south of the Russian plain is also submerged. Voronezh, Belgorod, Saratov, Volgograd, coastline or the floor of a warm, shallow sea. Those famous white chalk cliffs near Belgorod, along the Don and the Seversky Donets, they are literally the bottom of that ancient body of water, the compressed remains of marine plankton compacted over millions of years. The very name Cretaceous period comes from these deposits, and you are quite literally walking on that ancient seabed when you stroll near those cliffs. In that era, Crimea was not a peninsula, but an archipelago of several low islands. The Caucasus mountain system did not yet exist. Where Elbrus and Kazbek stand today, a deep water basin was lapping. The Caspian, the Aral, and the Black Sea had not yet been separated. It was a single marine system with an outlet to the Tethys. Most of Kazakhstan and Turkmenistan was shallow water, where mosasaurs roamed, and the Baltic region and a significant part of Belarus were also hidden beneath the waves. In Western Europe, the picture is no better. The Netherlands, Denmark, and northern Germany are entirely flooded. London lies underwater. Paris is a seaside town. And in North America, the heart of the continent is cut in half by a giant inland sea running from the Gulf of Mexico to the Arctic Ocean, the Western Interior Seaway. It turned America into two separate islands, Texas, Kansas, Montana. All of this was seabed strewn with ammonite shells. That is why today in Kansas, in the very heart of the continent, thousands of kilometers from the ocean, skeletons of sea lizards and giant fish are found. They swam where wheat fields now stand. Warmth was everywhere, not just in the tropics, but literally everywhere. In Alaska, sequoias and metasequoias grew. In Siberia, magnolias bloomed. Crocodiles and turtles lived above the Arctic Circle, and these are cold-blooded animals, which physically need warmth. If a crocodile lives above the Arctic Circle, that means it's warm there, an ironclad argument of paleoclimatologists. At the poles, winter temperatures did not drop below zero, and instead of ice, there stood dense forests full of animals, not tropical, but living, real. Paleoclimatologists call such a climate mesothermal. The seawater temperature at the poles ranged from 11 to 22 degrees, like the Baltic Sea in summer, only at the pole. This was a greenhouse planet, an incubator planet in which life filled every corner from equator to poles. There was no such concept as uninhabitable climate. Life was everywhere. And in this incubator, far to the south, lay one particular continent. But to understand its history, you have to rewind time even further, to the moment when all the land masses on Earth were a single whole. 250 million years ago, all the land on the planet was gathered into one giant supercontinent, Pangaea, one ocean, Panthalassa, one mass of land from pole to pole. If you had been standing on its shore and walked inland, you could have hiked from the future New York to the future Moscow on foot, without a single sea on the way, without a single strait. One continent, one landmass, one world. But the Earth does not stand still. Beneath the thin crust, in the mantle, the same thing happens as in a pot of boiling water. Hot streams of rock rise from the depths, spread sideways, cool, and sink back down again. This is convection, and it drags along everything that lies on top. The tectonic plates are the skin on the surface of this boiling liquid, and about 200 million years ago, that skin cracked. Pangaea split into two halves, northern Laurasia and southern Gondwana. Laurasia was the future North America, Europe, and Asia. And Gondwana is more interesting. One enormous landmass into which South America, Africa, India, Madagascar, Australia, and Antarctica were all pressed together, squeezed against each other like jigsaw pieces, one living organism. Life flowed across this supercontinent freely, without borders or obstacles. Dinosaurs wandered from what would become, 100 million years later, Argentina, into what would become Antarctica. And they noticed no difference. The same forests, the same rivers, the same ferns, the same diversity of animals. Antarctica was not a backwater. It was a full-fledged member of the big family, just as green and alive as Africa or South America. But about 180 million years ago, Gondwana too began to fracture. From the depths of the mantle plumes rose, gigantic columns of molten rock that burned through the crust from below and tore the continent apart. Picture a crack creeping along glass, except this glass is the size of half the planet, and the crack fills with magma and becomes a new ocean. The first to break away was Africa. It moved off to the northeast, and between it and Antarctica, the young Indian Ocean spread out. Then India tore off and raced northward at geologically insane speed, about 15 centimeters a year. Your fingernails grow at roughly that rate, but for a tectonic plate the size of half a continent, that's a race car. India tore across half the planet and slammed into Asia. And from that impact rose the Himalayas, the highest mountains on the planet, the scar from that collision, which is still growing today. Everest is rising by several millimeters every year. Then Australia slowly began to drift away, sailing northeast with its marsupials and eucalypts. And Antarctica slowly moved south. At first this wasn't frightening at all. It was still connected by an isthmus to South America in the west, still almost touching Australia in the east. Warm ocean currents freely washed its shores. Animals migrated back and forth. Antarctica drifted toward the pole, but it didn't matter as long as the ocean circulatory system of the planet was working the way it should. Warm currents from the equator reached the southern shores unobstructed, like central heating warming the continent from the outside. Life had no thought of going anywhere. Why would it, when it's warm, green, and there's food enough? A journey that would end in tragedy. Only no living creature on the planet knew it then. The Jurassic period, about 200 million years ago. The Jurassic world is the world of the dinosaurs, only just beginning to build their power and diversity. Antarctica is already far to the south and already inside the Antarctic Circle. The sun in winter slips below the horizon for several weeks, but the climate is warm and humid. How is that possible? Greenhouse effect. There is so much carbon dioxide in the atmosphere that even at the pole, there are no hard freezes in winter. Forests cover the entire continent from coast to coast. Tall coniferous araucarias with sprawling crowns, podocarps with dark, dense needles, a thick understory of tree ferns and mosses, thickets of horsetails by the rivers 2 human heights tall. This is not the tropics, but it is not tundra either. More like modern New Zealand, only without people and with dinosaurs instead of sheep. It is precisely in these forests that one of the most incredible stories in paleontology begins. At an altitude of over 4,000 meters in mountains that can only be reached by helicopter, the bones of a hunter from the jungle, 190 million years old. When these animals were alive, a river was flowing here through dense forest. In 1991, the American paleontologist William Hammer was working on Mount Kirkpatrick in the Trans-Antarctic Mountains, an altitude over 4,000 meters, a temperature of -30 degrees Celsius, wind strong enough to knock you off your feet. A helicopter dropped a small team onto a narrow rocky ledge, and right there, on that outcrop of Jurassic Age rock, Hammer found the large bones of a predator. It took 3 years to chip the rock free, transport it from the mountain, clean it, and prepare it for description. When Hammer published his results in 1994, the paleontological world shuddered. Cryolophosaurus, meaning icy crest, a theropod 6 to 8 meters long, one of the largest predators of its time, living 190 million years ago. Its main feature was its crest. In most crested dinosaurs, it ran along the head from front to back. But in Cryolophosaurus, it ran crosswise, from temple to temple, like a crown, or, as paleontologists joked, like the hairstyle of Elvis Presley. He became the first Antarctic dinosaur to receive an official scientific name. Next to him in the same rocks lay the remains of Cryolophosaurus, a large herbivorous sauropodomorph, a distant relative of the giant sauropods, those very long-necked giants everyone pictures at the word dinosaur. Predator and prey, side by side at the summit of an Antarctic mountain, sealed in stone for 190 million years. But these forests left us something even more astonishing than bones. They left a message. Scientists found fossilized tree trunks in Antarctic rocks with preserved annual rings. Each ring is 1 year of life. A wide one a warm summer, a narrow one a cold or dark winter. Through these rings, paleobotanists literally read the weather of 200 million years ago, a time machine built into stone. Wide summer bands spoke of active, greedy growth, while narrow winter ones testified that growth had almost stopped. Polar night, months of total darkness, this was already a reality back then, but life did not leave, it adapted. This was only the prelude. The real flowering of Antarctic life was still ahead, and when it came, Antarctica became one of the most astonishing places on the planet. Let us jump forward a whole 100 million years, the late Cretaceous period, 80 to 66 million years ago. Antarctica is still covered with forests, but now they are completely different. The monotonous coniferous thickets have given way to something far richer. Flowering plants have appeared, and they changed everything. Forests became more complex, multi-layered, fruits, seeds, nectar appeared, and this food revolution dragged a faunal one along with it. Where today there is a white desert, herds of duck-billed dinosaurs grazed, and predators with sickle claws hunted in dense forests. This is not science fiction. It is what scientists are unearthing right now. In the Argentine geologists Eduardo Olivero and Roberto Scasso were working on James Ross Island off the coast of the Antarctic Peninsula. In late Cretaceous outcrops they found bones, massive, covered with armored plates. This was the first dinosaur ever discovered on the territory of Antarctica, but the formal scientific description took 20 years. Only in 10,000 did it receive its name, Antarctopelta, Antarctic shield. A 4-meter ankylosaur clad in bone armor from head to tail, with a tail that ended in a bone club resembling a maquahuitl, an Aztec battle weapon. A herbivorous tank, peaceful but practically invulnerable. And he was not alone. On the same island they found Titanosaurs, a small ornithopod 1.5 meters long, fast and light, on thin long legs, the gazelle of the Mesozoic world. They named her after Trinidad Diaz, an Argentine geologist who had worked for decades in the harsh conditions of Antarctic expeditions. In Dutelsadevitnatsit, they described Imperobator, a predatory dromaeosaurid, a relative of Velociraptor, sickle claws on the hind legs, sharp teeth, lightning reflexes. This meant that real hunters lived in the Antarctic forests, fast, coordinated, dangerous. In the same place, remains of hadrosaurs, duck-billed dinosaurs, herd herbivores, grazing along riverbanks in whole groups. In 2000 Adensit, the first Antarctic sauropod was described from a single tail vertebra, and even from that, specialists determined a lithostrotian titanosaur, and therefore long-necked giants once walked along the banks of Antarctic rivers. And in 2020, something else happened. A German team from the Alfred Wegener Institute pulled up a core of sedimentary rock from the bottom of the Amundsen Sea and found amber in it, tiny drops of fossilized tree resin about 90 million years old, the first amber ever found directly on the Antarctic continent itself. There were no insects inside, no Jurassic Park has worked out yet, but the fact itself is priceless. Direct material proof that healthy coniferous trees grew here, releasing resin under the rays of the Antarctic sun 90 million years ago. That is what Antarctica was in the late Cretaceous. Armored ankylosaurs, fast ornithopods, predators with sickle claws, long-necked titanosaurs by the rivers, hadrosaurs grazing in herds, forests of araucarias, podocarps, ferns, and the first flowering plants, pterosaurs over the shores with leathery wings several meters wide. Life in every niche, from roots to crowns, a full-fledged ecosystem on a continent that stood practically at the South Pole. If you're enjoying what you're learning, hit like. That helps the video reach those who'd also be interested. Because we haven't even gotten to the most interesting part yet, since this green, living world had one peculiarity that stumped scientists for decades. In the late Cretaceous, Antarctica stood almost at the South Pole, and that meant one inevitable thing. 3 to 4 months a year, total darkness, no sunrise, no sunset. The sun simply does not rise above the horizon. Months of unbroken night. And here is the question that gave paleontologists no peace. How? How did dinosaurs, large, active animals that need food every day, survive without sunlight for 3 or 4 months? Without sunlight, plants do not photosynthesize, do not produce food, do not grow. Without plants, herbivores have nothing to eat. Without herbivores, predators have nothing to feed on. The whole food chain should have been collapsing every winter. So where do all these fossils come from? For 30 years, science could not explain how this was possible. Scientists proposed 3 hypotheses. The first, migration. With the onset of the polar night, dinosaurs went north toward the light, like modern migratory birds, thousands of kilometers on foot in autumn and back in spring. Logical, supposedly, but the path from the pole to warm latitudes is very far, especially for a 4-ton ankylosaur. Doubtful. The second, hibernation. They entered torpor, slowed their metabolism to a minimum, the way modern bears sleep for 3 or 4 months, exactly the length of the polar night. Possible, but traces of hibernation are hard to find in fossils. The third, adaptation. They went nowhere. They did not sleep. They developed night vision and continued to live in the darkness, hunting, feeding, reproducing. And then a discovery came along that set everything in its place. Scientists found the bones of a dinosaur that had only just hatched, right in the middle of the polar night. In Alaska, which in the Cretaceous also lay above the Arctic Circle, paleontologists found bones of dinosaur babies. Not just young individuals, but perinatal ones, just out of the egg. Tiny bones of newborns of several different species, right in polar deposits. A baby that had just hatched cannot migrate thousands of kilometers. It can barely stand on its feet. So its parents did not migrate. They lived at the pole year-round. And this logically extends to Antarctica. The polar dinosaurs of the south most likely did the same. They stayed. They had the tools for it. Remember Liaelinosaura, a small ornithopod from southeastern Australia, which in the early Cretaceous lay right next to Antarctica at the very South Pole. It had abnormally large eye sockets and enlarged optic lobes of the brain. Patricia Vickers-Rich and Tom Rich of Melbourne studied these polar dinosaurs for decades and came to the conclusion that large eyes were an adaptation to life in conditions of prolonged darkness. Night vision that allowed it to see where others were blind. Modern polar animals confirm this model. Reindeer live above the Arctic Circle year-round. Their eyes change color in winter to better catch the scarce light. Evolution solves problems like this, given enough time. Picture this world, an Antarctic forest in polar night. Silence, huge coniferous crowns closing high overhead, and moonlight barely filtering through. A layer of fallen needles underfoot. Somewhere in the darkness a branch snapped. A small ornithopod with huge eyes carefully picks its way between the trunks, sniffing out mushrooms and rotting ferns. And behind it, silently, from tree to tree, a predator stalks. 2 dim discs of eyes catching every photon of moonlight. 3 months of darkness, and in that darkness life boils. Life found a way. But the planet was preparing something from which no way of saving yourself existed. Before telling about the catastrophe, the full picture must be shown, because life in Cretaceous Antarctica was not only on land. The seas around this continent were a completely separate universe. In the warm Antarctic waters, creatures the length of a city bus glided through, with flexible necks snatching fish right here, where icebergs float today. The water at the shore was 15 to 20 degrees. Shallow shelves stretched hundreds of kilometers from the land. And in those waters, not just a rich haul, but a real parade of sea monsters unfolded. Plesiosaurs, marine reptiles with 4 powerful flippers and long flexible necks. Not dinosaurs, but a completely separate branch of reptiles that went into the ocean back in the Triassic. On James Ross Island, the same one where Antarctopelta was found, paleontologists discovered skeletons of giant elasmosaurids, marine reptiles the length of a city bus, sliding through Antarctic waters and snatching fish and small mollusks with their long necks. In 27 Nazi, a new mosasaur was described in Antarctica, Kaikaifilu, a 10-meter marine predator with massive jaws, the top of the food chain, and everything that swam in the Antarctic seas was its potential lunch. The name is taken from the mythology of the Mapuche people, lord of giant lizards. Around these giants, ammonites, spiral mollusks of every size from a fist to a dining table, and some species in the world ocean reach 2 meters in diameter, taller than a person. On the Antarctic bottom, their shells are found by the dozens, imprints of spiral homes in which a soft body with tentacles once pulsed. Sharks, whose appearance has barely changed in hundreds of millions of years. Sea turtles with shells the size of a bathtub, and that is not an exaggeration. Bony fish, hundreds of species, forming the base of the food chain, land and sea together. The whole continent pulsed with life from mountain peaks to seafloor, a full-fledged world with a multi-level ecosystem, millions of years of evolution, billions of living creatures, predators and prey, everything in place, everything balanced. If you could have dived into the Antarctic Sea of the Cretaceous, you would not have believed this was the same place where icebergs float today. This whole world, built over 150 million years, collapsed in a few years when death fell from the sky. 66 million years ago, on an ordinary day in the late Cretaceous, when the dinosaurs of Antarctica were busy with their usual affairs, the Chicxulub asteroid, a piece of stone and metal the size of Everest, about 10 kilometers across, slammed into the Earth in the area of the Yucatan Peninsula in modern Mexico. Speed 20 kilometers per second, 60 times faster than a bullet. The energy of the impact, greater than the entire nuclear arsenal ever to have existed on the planet, multiplied 1,000 times over. In the first seconds, a fireball that scorched everything within a radius of 1,000 kilometers, mega tsunamis hundreds of meters high rolled across all the oceans. Global wildfires swept across the continents. Then nuclear winter. Dust and soot blocked the sun for months, maybe years. The temperature plunged. Photosynthesis stopped. Plants died. Behind them, herbivores. Behind herbivores, predators. Food chains collapsed across the whole planet. 75% of all species on Earth went extinct. All non-avian dinosaurs, mosasaurs, plesiosaurs, ammonites, pterosaurs, gone. In a few years, what had been built over 150 million years collapsed. Antarctica survived, not in its entirety, of course. Imperobator, Antarctopelta, hadrosaurs perished here, as they did everywhere. But the forests, battered, decimated, stripped of most of their inhabitants, endured. Birds, descendants of those very dinosaurs, kept flying. New players stepped onto the freed stage, mammals, small, furry, inconspicuous creatures who had been hiding in burrows beneath the roots, in the shadow of dinosaurs, for 100 million years. Now the shadow was gone, and their time had come. Antarctica survived the asteroid impact, survived the greatest mass extinction in 200 million years. It even recovered, not right away and not in its former shape, but it recovered. Forests turned green again, new animals took up empty niches, life returned. But what eventually killed it was far slower and far more terrifying. The Eocene, about 40 million years ago, Antarctica's last summer. This is perhaps the most astonishing chapter in this whole story, and we know what it looked like not from bones and not from coal, but from a few pinches of pollen lifted from the ocean floor quite recently. In 2010, an international team of scientists aboard a research vessel set out for the shores of Wilkes Land in East Antarctica, drilled the seafloor, and pulled up cores of sedimentary rock 50 million years old. In these cores, they found pollen, palm pollen, palms in Antarctica. Next to it, pollen of baobab-like trees. The results were published in the journal Nature in 2012, and they shocked even those who had obtained them. The water temperature off the coast of Antarctica in the early Eocene, plus 20 degrees, water in which you could swim. In summer on land, up to plus 21 degrees, like Sochi in September. The winter mild and frost-free. Even in polar night, the temperature did not drop below plus 10. These are data from analysis of archaeolipids in the same cores, an independent geochemical thermometer. The pollen says, "It's warm." The lipids confirm, "Yes, it's warm." Two independent sources, one result. In this warm world, a completely new fauna flourished. On Seymour Island, a key paleontological locality, they found remains of marsupial mammals, relatives of the modern Monito del Monte, a tiny nocturnal creature that still lives in the forests of Chile. They found primitive no-toe ungulates, the South American private horses, which had no relation to true horses but occupied the same ecological niche. They found fossilized fungal spores and pollen of dozens of plant species, a full-fledged, complex, multi-tiered world. Rainforests where beneath the palms marsupials rustled, in the crowns birds sang, and on the forest floor mushrooms grew. In the Eocene, Antarctica was not just a living continent, it was a bridge, the last terrestrial corridor between South America and Australia. The marsupials that live today in Australia, koalas, kangaroos, wombats, their distant ancestors came from South America by way of Antarctica. This continent, icebound today, was the main evolutionary crossroads of the Southern Hemisphere. Without Antarctica, there would be no kangaroos, no koalas, no wombats. All the unique fauna of Australia passed through it as through a transit hall. But gradually, so slowly that no living creature could have noticed it within its own lifetime, the world was changing. Carbon dioxide in the atmosphere was falling, and not because of people. People would not exist for another 50 million years. Just geological processes, volcanism weakened, and rocks as they weathered bound atmospheric carbon dioxide. Those very Himalayas, remember how India slammed into Asia? Those mountains as they rose exposed vast areas of fresh rock that reacted with atmospheric carbon dioxide and sealed it into stone. Chemical weathering, a natural mechanism that pulls greenhouse gas out of the air. That very greenhouse effect that had kept the planet warm for millions of years began to weaken. The planet's temperature crawled downward, degree by degree, epoch by epoch. Tropical plants began to vanish from the Antarctic forests. Palms gave way to southern beaches, Nothofagus. These trees tolerated cold, but did not love it. While the palms withdrew, the Nothofagus took their place, not because they were stronger, but simply because they could endure what the palms could not. Heat-loving species died off one by one, mammals grew smaller, forests thinned. This did not look like a catastrophe, it looked more like a fading. Not a fire, but a smoldering. Not an explosion, but a slow cooling. An endless, slow, irreversible autumn stretched across millions of years, and no one noticed that the days were growing colder. But for a real winter, one final event was missing, one last click, and it came. About 34 million years ago, Antarctica finally tore away from South America. The last land bridge, the last thread that had tied it to the rest of the world, slipped beneath the waves, and between the two continents a strait opened. Today we know it as the Drake Passage, named after the English pirate and navigator Francis Drake. 800 kilometers of turbulent ocean between Cape Horn and the Antarctic Peninsula. Sailors call this place the Roaring Forties and the Furious Fifties, waves the height of a 5-story building. A trifle, you'd think, a crack between two continents. But this crack killed a whole world. When the strait opened, the cold waters of the Southern Ocean for the first time received a closed, circular route around Antarctica. Previously, warm currents from the equator and the tropics had freely reached the shores of the continent and warmed it like radiators of central heating. Now a wall of moving water stood in their way, the Antarctic circumpolar current, the most powerful ocean current on planet Earth. The continent found itself trapped, locked inside a ring of icy water, cut off from the heat, one-on-one with polar cold. And Antarctica began to freeze, and with positive feedback. The more ice, the more white surface. The more white surface, the more sunlight reflected back into space. The more light reflected, the colder it gets, and the more ice forms. This is glacial albedo, a self-amplifying cooling mechanism. Once it kicked in, stopping it was already impossible. Not in a single day, not in a single century, but by the standards of geology, swiftly. Over a few 100,000 years, which for the planet is like a few minutes on the scale of a human life, the temperature plunged. Glaciers began to grow from mountain peaks. Snow that used to melt over the summer stopped melting. Year after year piled up, compressed, turned to ice, and crept down toward the coast. Forests died. First, the last tropical species vanished. They were already on the edge. Then the trees of the temperate zone. The last to hold out were the Nothophagus. These trees still grow today in Patagonia, on the South Island of New Zealand, on Tasmania, the last descendants of those very Antarctic forests. But on Antarctica itself, they clung to coastal lowlands, to the last scraps of land where ice did not yet lie. A small grove on the shore, all around it white, snow that no longer melts even in summer, a glacier creeping down from the mountains like slow-motion lava, only cold. The annual rings of the trees grew thinner with each century. Roots could not break through frozen soil. Summer grew shorter. After a few million years, it was all over. Antarctica turned into what we know it as today, a white ice sheet from horizon to horizon, the coldest, driest, windiest place on the planet. Minus 89.2 degrees, the absolute record minimum temperature on Earth, recorded at the Soviet Antarctic Vostok Station in 1982. But the story does not end there, because here's the thing. Everything that was, mountains, canyons, valleys, riverbeds, the remains of forests, has gone nowhere. Nothing disappeared, nothing was destroyed. It was simply hidden, buried beneath the largest freezer in the history of the planet. Beneath a 4-kilometer ice sheet lie the Gamburtsev Mountains, a mountain range comparable in size to the European Alps, with peaks rising to 3,500 meters. No human being has ever seen them. We know about them only because aircraft fly over the glacier, scanning it through with radar. On the screens, ghostly silhouettes of mountains that last saw sunlight when saber-toothed cats still roamed the Earth, and maybe earlier. No one knows exactly when the ice covered those peaks for good. The Gamburtsev Mountains are over 1 billion years old, and how they preserve their height under such pressure of ice is a separate puzzle scientists are still trying to solve. Even deeper, Lake Vostok, the largest subglacial lake on the planet, 250 kilometers long and 50 wide, isolated from the surface for hundreds of thousands of years. Russian scientists drilled a borehole down to it over several decades, breaking through almost 4 kilometers of ice. And in the ice core, in water that had frozen onto the bottom of the lake from below, they found bacteria, living microorganisms cut off from sunlight, from the atmosphere, from the entire world. Beneath 4 kilometers of ice, live bacteria that have not seen sunlight in hundreds of thousands of years. Life that refuses to surrender, even when the whole world around it has frozen. More than 400 subglacial lakes have been discovered beneath the ice. Vostok is the largest, but not the only one. Beneath Antarctica lies an entire network of bodies of water that may hide unique forms of life unknown to science. Coal seams, Direct remains of those very forests in which Cryolophosaurus and Antarctopelta once roamed lie across the whole continent, fossilized memory of a world that is no more. Every field season, paleontologists find new fossils, new species, new evidence. They can work only a few weeks of the year in the narrow window of Antarctic summer at -20 and a wind that knocks you off your feet. Scientists literally dig bones out of frozen rock, warming their tools with their breath. But every season brings surprises. The radar maps of the BedMap project show entire mountain ranges beneath the glacier, wide valleys, deep canyons, some deeper than the Grand Canyon, and subglacial rivers flowing under the pressure of kilometers of ice. On the radar screens, contours of relief that look like a satellite snapshot of an ordinary continent, only one hidden under ice. This is not dead rock. This is a landscape, a whole world, preserved like a fly in amber. And scientists keep drilling. Every meter of core is a page from a book the planet has been writing for millions of years, a page we are only just learning to read. The ice has kept this secret for 34 million years. But there is one question that is making scientists nervous right now. What if this ice begins to retreat? Because it is already retreating. The Thwaites Glacier, the Pine Island Glacier, the largest glaciers of West Antarctica, are losing mass faster than the models predicted. Warm water is undermining them from below, imperceptibly, like termites eating away at a house. If this process continues, the ocean level will rise. Not by 100 meters as in the Cretaceous, but even a few meters will redraw the map of the modern world. Write please in the comments how this story landed for you. It really matters to me to understand whether it gripped you. What do you think? Were the polar dinosaurs of Antarctica being smarter when they stayed to overwinter in 3 months of darkness? Or when they walked thousands of kilometers north?